Okay, this is example 2, another system of linear equations. Again, we're focusing on lines, linear models in this first part. So again, we have two equations, right? We can call this line 1 if you'd like, and I just color-coded line 2. And let's go ahead and graph the lines, right? Using the information we learned in section 7.1 and 2. I'm going to go ahead and start with line 2 just because so let me just write this down because this one's ready to go. Y equals 2 minus 3x. Well, that is already in slope-intercept form, which is another, again, an alternate method to graphing a line. So we know the slope and we know the y-intercept. So the slope, is the number in front of the variable, which is the coefficient. So we have -3. Right, or -3 over 1. So we want to write, the slope is a fraction, and we want the fraction because we're thinking of rise over run. So this is up 3 or down 3, and it's negative, so it's going to be down 3. And this is going to be to the right 1. What is our y-intercept? Well, that's the point where the line crosses the y-axis, right? Hence the name y-intercept. So it's always 0, comma b. And our b in this case is my 2, right? This is really written as, b plus mx, right? Or mx plus b. If you want to switch it, that's fine. Okay, 0, 2. And I'm going to go ahead and plot this in graph. And here I don't have a straight edge. So I'm going to do my best to make this as straight as possible. Okay, that's bad, but y-axis, and then let's see, then we have the x-axis, okay, which again, you should use as a straight edge. You should use a straight edge. That's going to be part of the directions, and we had 0, comma 2, so let's see, that was in blue. So here's our 0, comma 2, and our slope was, oops, I believe -3, so down 3 to the right 1. So down 3, so there's 1, 2, 3, and then to the right 1. And there's how we find a second point, right? And again, if you want to go down 3 again, and then to the right 1, you find another point. And I'm going to draw this, connect these points, and again you should use a ruler because again it's going to be very hard to find that point of intersection if there is one. So this is well, it's good that I'm not using a ruler so you can see how ugly this looks. Okay, so that is done. We're done with line 1, so let's move on to line 2, which is 6x plus 2y equals 7. And again, I'm just going to go ahead and use the slope-intercept form. Again, if you want to use a different method, that's fine. So let's solve for y. So I'm going to bring my 6x over, and then I have 2y equals 7 minus 6x. Again, this part is an intermediate step. If you want to skip it, that's up to you. I encourage you to write it. Again, just to prevent any errors. Usually the errors are by skipping steps. And then I'm going to multiply it by 1/2, which we know from our fraction review is just dividing by 2. And that's really y equals 7/2 minus 3x. And again, I'm just going to go ahead and rewrite this as y equals -3x plus 7/2. You don't have to rewrite it, but it's kind of nice because you see the mx plus b here. So we notice that our slope is still -3, right, as above, and our b, right, our y-intercept is 0, 7/2. Well, that's the same thing as 3.5, right? Half of $7 is 3.5. So let's plot our 3.5, which we know is going to be on the y-axis. So 3.5, right, is going to be right there. Right, 0, 7 halves. Now remember, our slope is -3, so we have to go down -3. But remember, okay, so each of these guys, right, this is 1, this is 2, that's 3, 4, right? Maybe we can label this is 1, 2, and we're working in halves, so might as well cut everything in halves, right? If you're working in thirds, then you would cut everything in thirds, fourths, and so forth. So we want to go down 3. So let me again zoom in a little bit. So we have down 3. So if I go down that unit, that's only going down a half, okay, not 1, right? Because 1 would be the whole thing. So here's a half, and here's another half, assuming, again, my halves are, my other half really should be here. That's actually a really bad half. But here's a half, here's another half, so that's going down 1, 1.5, 2, 2.5, and then 3. So there, that's where I'm going. I'm going down 3, and right, because it's really 6 halves, right? 6 halves. Well, half of 6 is 3, and then we're going over 1, and then there's my new point. And if I connect these two dots with a straight edge, and you have to, again, write the arrow. These lines actually do not intersect. These are parallel lines. So parallel lines, which are basically lines that do not intersect, specifically because they have the same slope. So M1 equals M2, and if you want to label, right, this is like your, whoops, this is like your M1, right, your first slope, and then you have your second slope, which is exactly the same. And again, we have a solution to this system when the two lines intersect. Well, where do they intersect? They don't intersect. So here we can say this system is inconsistent. Right, there's no solution, or you can write the 0 with the slash, right? There's an empty set here. The solution, what is it? Well, there's nothing. There are no points. There are no XY pairs that satisfy that system. So we have, well, we don't have to talk about independent or dependent lines because there's nothing interesting here. There's no solution, so there's nothing to really elaborate on. So that's another example of solving a system by graphing.